All right, so I'm jumping page 135, 137, number 3. And let's see what we can do. And again, you see this, you're like, I know how to do these. We're going to get to some other thing. Hopefully never do all. All right, number 3, it says a particle moves along a line with a velocity given by this. The total distance traveled from 0 to 3 equals what? What would you do? And remember, even if it's multiple choice, guys, I really want you guys setting everything up. I give like 1 point for the correct answer. 1 point for parts of the setup, 1 point for calculation. So make sure you're showing all of it to me. I just make some of them multiple choice to get you in the habit of seeing those and how to let answers sometimes help you. So if I give you velocity, how am I going to get total distance out of that? You say set up the integral of v of t. So if I did that, and I've heard the correct thing and the partially correct thing, if I do this, I'm not going to get distance, I'm going to get change in the position. So absolute value if you have a calculator. All right, now that's great. If you have a calculator, type it in, great. Tomorrow, I said you don't have the calculator, right? So what do you do tomorrow?
You would equal it to 0.
Okay, yeah, because remember, I don't know that this velocity function is only going to give me positive values. I don't. If it did, like, let me ask you this. If I put a plus right there, is there any way for velocity to be negative?
Yeah.
Not on the interval from 0 to 3, there's not. Are you with me? So like if you happen to notice that, that's a gift. Because you can go, oh, sweet, I don't have to worry about. And look, even if it was plus that, if you set that equal to 0 and solve by factoring this out, what ends up happening? You get 0 and -2, right? Well, the breakpoints, it begins and ends at 0 and 3. -2's over here, right? It's not even in my interval. So I really don't have to break it from 0 to 3. It's all positive values. There's no way to plug in numbers from 0 to 3 and get a negative out of that. Now, that wasn't the question, though. It was minus. So on a minus, if I don't have a calculator, I've got to figure out where it crosses, right? Because if it crosses the x-axis in between 0 and 3, one of those is positive, one of them is negative. And it clearly crosses at 2. So I find this by saying, well, the integral from 0 to 2 and the integral from 2 to 3, and then I don't need the absolute value. And it might just be, say, set it up. Because this is really a lot of junk to plug in, although this one's not bad. But how do I know which one's positive, which one's negative area without going through the process of finding the area? And by the way, if I have to find the area, then just find it. And whatever's negative, like if I end up with a negative area here, change the sign up there. If I end up with a negative area here, change the sign. But if I only was writing the expression, what would I do? Yeah, pick a number between 0 to like 1, plug it in there and see if I have negative y values. That would let me know where the graph is, right? If I plug a 1 in there, I get 3 minus 6 is -3. That tells me in that interval, the graph was below the x-axis. That must have given me negative area. I don't want negative area. Now it's positive area. And from 2 to 3, if I plug like 2.5 in there, which is not fun, but if I did, I'd get 6.25 times 3 is 18, 19-ish, minus 13-ish, right, which is positive. And don't just assume that, oh, if it's positive on one, it's negative on the other, because it could be a bounce, right, and be positive on both or negative on both. But again, you would know that if there's a double root. But whatever, that would be this. And then from there on out, remember to integrate, right? I'm going to keep this negative on the outside. I'm going to start putting my stuff in there. But when I integrate it, I get t cubed over 3 times 3 minus 6t squared over 2, which is 3t. I get that from 0 to 2. Don't forget the negative is out there. So what, are y'all with me? Oh, sorry, 3t squared. So when I do this, I'm going to go ahead and put that negative there and say 2 into that gives me 8 minus 12. 0 in there gives me 0. So I have all of that negated when I'm done. And then over here, I'm going to plug, again, same integral, right? So plus t cubed minus 3t squared, this time from 2 to 3. You guys get in the habit of putting the line with the 0 to 2, the line with the 2 to 3. It's not about your answer, it's about your setup and your work as well. Like AP is going to give you like something like this. All right, probably a half a point or a point for finding that 2, for knowing that. For splitting it up, maybe a point. For integrating correctly, maybe a point. For writing the 0, 2, 2, 3, maybe another half a point, whatever. All these points come together and then an answer. So here, plug a 3 in there. 27 minus 27 is 0. 8 minus 12 is negative 4. So I end up with positive 4, 8.
Wait, why do you have a negative outside of the first one above the? Nope, down into the right. Yep.
Because of that?
But all right, so you just moved it down again.
Yeah. The integral was this part. The negative I'm just bringing down.
Okay.
Why isn't that an answer? Oh yeah, none of these. I wouldn't have thought I could do that. Next one I want to look at is number, not as many from this one. There's good questions on here. 209. This is a 2009 AP question. Okay, and it gets a little wordy. AP does this. When you see these, you got to just, again, slow down, catch certain phrases. The rate. And anytime I see rate, I'm thinking, oh, rate, integrated rate, get amount. I'm always thinking that. May not be what I need, but I'm always thinking that. The rate at which people enter the auditorium is given by this. So that is a rate from 0 to 2. It's measured in people per hour. No one's in the auditorium at time 0 when the doors open. The doors close and the concert begins at time 2. Is everybody with me?
Yep.
A, how many people are in the auditorium when the concert begins? Now, I check it a little easy on you because a lot of people go, oh, you integrate a rate, you get an amount. You integrate a rate, you get a change in the amount. Then you would add that change in the amount to the initial, right? But AP cut you some slack and said there was no people in there. There were no people in there. So if you didn't add it to 0, you would have still been okay and got your points. But remember, right here, how many people? The number of people is the change in the amount, which is what do you do for that? You integrate that rate. And by the way, if it's a calculator question like this one is, you're going to type in your calculator that, but you don't have to write that. You could just write this. That is the change in the amount, right? And then the initial amount, which is 0. And you don't even need to do that here. Literally, that is the change in the amount of people. So that's how many people are in the auditorium because at time 0, there were none. Are you with me? Okay, so that's really all you would have to do. Type that in your account and your whatever, and it spits out 980.
Would we have to write the plus 0?
No. On this particular one, do I have there? No, I don't have theirs right next to what they pointed it out with, but no, you don't. But again, they're being kind. I don't know why they did that. Just super nice, trying to give somebody a point or two that doesn't know what they're talking about. But most of the time they would say, 100 people. 100 people are in the auditorium at time 0, and they would be looking for 1 point for this setup, 1 point for this, or maybe 1 point for the setup and 1 point for the correct answer, because the correct answer would have only been achieved had you added 100. So probably more like this, which would have been you accommodating for both. But that's not the case here, right? All right, next question. Find the time when the rate at which people enter the auditorium is maximized. Find the time when the rate is maximized. When is a rate maximized?
The derivative is 0 and goes from positive to negative.
That's relative maximized.
Oh.
Be careful. When is a rate maximized? Although that will get you in the neighborhood, at least you're looking at relative maxes. But remember, maximized could also be when? At endpoints. So for maximized, if I say, when are you maximized? You would say, well, I definitely want to know where the derivative of R is what? 0 or D and E, and check endpoints.
Well, it's not the first endpoint because there are no people.
Well, but hold on. It says the rate at which is maximized, not the number of people is maximized. So I want the rate to be maximized. So what would I do to figure this out? What would you do? It's a calculator
I
problem.
would just graph it. and work
Graph
it.
what?
The derivative function.
So graph the derivative of that. Does everybody know how to do that? So you go to your calculator and what are you going to type in? Say you have a TI-84. Y1 equals what? What are you graphing? Are you going to manually take the derivative of this?
No.
You can, but you don't need to, right? You can go math 8 or whatever, ddx. You can ddx your r function, 1380t squared minus 675t cubed. And I would encourage you to do that because you could make a careless error taking the derivative manually. It's a calculator. Don't forget that you have it in your hand. So when you graph that, what would you be, and by the way, do it on the interval from 0 to 2. So when you graph that on the interval from 0 to 2, what do you find out? Well, I'll tell you what, I'm not going to bother graphing it, but you actually find out that at t equals 0 and t equal 1. 1.36296. That's where the rate was either 0 or undefined. You don't have to do this. They don't even want to see this. They want to see the derivative of our 0 d and e at those, okay? Actually, just say at those. And then they want to see you actually checking for maximum rates. How do you show your check for maximum rates? Rate at the 0, rate at the 1.36296, and also the rate at the 2, right? Because that's the endpoint. But they want to see this statement. Where is the derivative, 0 d and e, and then they want to see you checking them. They don't care. When I say max or min, nobody cares about, oh, it goes from plus to minus there. We don't care. That's how you check for relative maxes. And relative maxes, you might not have one at an endpoint. Or you won't have one at an endpoint, right? Because it can't go from one to another. It's done. But you got to show you're checking the endpoints and the critical numbers.
Theoretically, could you just graph the actual rate function and then look for a maximum?
You could. That's a great, I'm glad you brought that up. You look at the numbers on this thing.
It's very big.
Yeah. So sometimes the numbers are deceptively big. Like right here, you can look at them and go, yeah, at t equals 1, I'm already up 600 something. I'm way up there. So you got to start hunting, changing your window to make it fit. But sometimes they give you functions that you wouldn't look at that and it wouldn't seem so obvious, right? So you're looking at it and you're like, where's my picture go? And you're changing it. And pretty soon you realize, oh, my graph is up there at 72,000. And you spent 5 minutes trying to figure out what did I do wrong? What did I do wrong? Where if I'm finding where it hits 0, all I got to look at is the x-axis, right? Who cares what the y's are? Make y negative 10, 10, negative 3, 3. Doesn't really matter. I'm just looking at where it hits 0. So yes, you could do that. That's not using calculus. You're not going to get credit for this statement. So if all you did was say, oh, I looked at my graph and I saw that it was maximized. It turns out here it was maximized at 1.3. So yeah, if you just graph that rate function, you'll see that it's at its highest point right here. This was 854.527. And remember 3 decimal places, guys. And then this was 120, and this was 0. So clearly maximized there, but remember to answer the question. What was the question? Find the time. So what's the time? Yeah, so at t equals 1.362, I'm just going to call it 363. What is this, hours? Hour. All right. All right, moving on from that, I want to jump to some good stuff on this, lots of good practice on all of this, but I want to jump to that take-home quiz, which I'm not taking up, but if I were you, I'd do it, but whatever. That pretest is good stuff too.
So where's the take-home?
The class presentation problems, we don't do those anymore. There's a lot of stuff I put here at the end, guys, for you to mess around with. Okay, so I'm jumping to 149 right now.
Yep.
Okay, so look at number 2. It's been a while since we talked about these. Remember these?
Yep.
So you got, the limit of the sigma notation. So this is actually the real definition of the integral, right? But that's not meaning a lot to us right now. And we're certainly not going to pull out all our sigma notation formulas for adding squares and cubes and all that. We don't even know those. Even the ones that learn those probably don't remember those. So how do I look to this and convert it to an integral that I can actually evaluate?
The base is going to have 3 over
Okay, so you see, I'm on number 2. What am I on, 2?
1.
I'm doing number 2.
Oh.
On number 2, so I see 2 over n, 2 over n, 2 over n. So the base right here is 2. That's not the base. That's the difference from what? The difference between a and b, which is part of that base expression.
And the start.
Right? So, and then the start, I can see right there, I'm starting at -1 because that was what got plugged into my function. So if I start at -1 and the difference between a and b is 2, that means I'm going to +1. And then now I can get started. Okay, what was the function then?
4x squared minus 7x.
Okay, do y'all see that? I basically am ignoring this 2 over n because it doesn't have an I with it. So it looks like I plugged that and that into 4 blah squared minus 7 blah. So 4x squared minus 7x. Don't forget your dx. And then now I can integrate. So to integrate, 4x cubed over 3 minus 7x squared over 2 in parentheses from -1 to 1. I want to write that expression, and then I want to apply the fundamental theorem, which says once you have your integral, you do plug a 1 in, 4/3 minus 7/2. You plug a -1 in, -4/3 minus 7/2. And then you subtract these two. And when you distribute that negative in, you see that the -7/2 and now the +7/2 are canceled. And you get 8/3. You with me? So again, make sure you go back and review those and also know how to go from an integral to one of these. All right, I think we did a number of practice problems on that, a couple homework problems on that or whatever. If you want to go back and look at those. Jump to number 4. If R is the rate at which water is pumped out of a tank in gallons per minute, write an integral that represents the amount of water that has gone out of the tank in the first 3 minutes. In the first 3 minutes, how do I write that? I want to know the amount of water that has gone out of the tank.
The integral of the velocity from 0 to 3.
So the integral of RT, right, which is the rate, the integral of RT dt says the first 3 minutes. So 0 to 3, that would be the change in the amount or the amount that has left. Y'all seeing it?
How would you evaluate number 3?
Number 3? It's the second fundamental theorem, right?
Well, I know how to write it, but it says write it and then evaluate it.
That was for number 2.
Oh.
Sorry. Number 3 is just
It's just
here. Yeah. All right, check out number 6. We have actually not talked about these, but I think they make sense. And I always have students that tend to have a little issue with these. So think about it. What is this integral saying? That first of all, the same function is being used for all 3. What is this saying? That the area under the curve of f, or between the curve of f and the x-axis, from -2 to 0 is -6. Okay? Now that doesn't mean that it's all negative there, right? It could be part negative, part positive. I don't know. but the total is negative. And then this says the area from what? From 3 back to negative 2 is 5. And then this says the area from 0 to 5 is 10. And then I turn around and say, based on all that, can you answer all these questions? So let's think for a second. Clearly, the points at which things are being measured are -2, 0, 3, and 5, right? So why don't we do this? Why don't we just kind of think, all right, I got -2, 0, 3, and 5. Those are the critical points. And you know what? I hate, personally on these problems, and you might experience this in a second too, when one of the functions is measuring from left to right, and then the other one measures from right to left. I'm not a big fan of that. So what I do on those is I get them all going the same way. And how can I do that? That's right. So if I change that 3, -2 to -2, 3, that just makes that a -5. So here's what I do. I go, all right, I think of these almost like variable expressions. -2 to 0 is -6. So from here to here is a -6. -2 to 3 is -5. Here to here, total is a -5. Well, what does that tell you about this? What's the only way this sum or this area and this area adds to -5? If that's a +1. Does that make sense? I'm just kind of thinking about this almost like an algebra equation. So that means here to there is a +1. Then it says 0 to 5 is 10. If 0 to 5 is 10, that whole total amount is 10, then what does that tell you about this part? Do y'all see that? Yes, no? So I'm setting something up to kind of help me visualize the parts. And then from that, I'm going to go and see if I can do stuff. What's 0 to 3? What's 3 to 5?
9.
What's 0 to -2?
6.
Yeah, because -2 to 0 is -6, 0 to -2 is 6. Now, let me throw you a curveball it's not on here. What would happen if I made this 3f of x? It's not a huge curveball, but what could you do?
Just be 3.
Couldn't you factor the 3 out? Right? Is that a big deal? Okay, if I factor the 3 out, 0 to 3 is 1 times 3. Okay, now, here's a curveball. And I don't know that you have all the information to answer, but I want to see if you can translate. What if this said f of, but if I did give you something like this, I would give you the information. What if I said that f of x minus 2?
You just translate it to the
Can you undo that x minus 2? Like, think like this. If it was integral from 3 to 5 of regular f of x, right? And I don't know why I don't have the dx's on here. That's, I could put them in their bad form on my fault. Isn't this big F of 5 minus big F of 3? I don't know what the big F is, but isn't it what that is? What do I end up with here? Big F of 3 minus big F of 1. So what is this really the same as? Yes. Are y'all seeing that? Of little f. And again, I don't have enough information on this one. But if I gave you enough information, like what if you knew what was from like 1 to 3, you could go in there and use that if you had all that information. I just didn't give you any intervals of 1. But do you see how to translate that to this? I'm basically thinking, well, if this is that, which it is, a new function, 5 minus 3, well, then I ended up, when I plugged a 5 in here, with this, and that's the same thing as this, so I can do this now and find the error from 1 to 3. And again, I don't have enough information to do that in this problem. I'm just making this stuff off the top of my head. But do you see kind of how that plays out?
It's a little bit tricky.
A little bit? Y'all with me?
Yeah.
Okay, what about this? What if instead of having f of x, I had f of 2x dx?
Same process.
Now, wait a minute. What do I have to do? I have a rule. This is how I use people with u substitution. I just take it for granted. My rule says an integral of an f of an x function from a to b is a big F of b minus a big F of a. That's if it's x. If it's anything else, or if it's f of u du, that's true. But if it's f of 2x, you have to make it change first. So how do you do that?
Put 1/2 outside.
I go, if u is 2x, du equals 2 dx. I need a 2 there and a 1/2 there. 1/2, 0 to 3, right, 2 times this, of f of u du. So now, what is this equal to? You gotta be careful. 1/2 times what?
F of b minus F of a.
Actually, you know what? I can't get into that, Miss. I haven't taught you this thing.
What is it?
I can't do this yet.
No.
Well, this is what really happens. I'll just show you. That always bothered me in class. Felt like I was cussing or something.
Why?
That's you, man. I mean, just like,
Whoa. So high.
right here. So right here, stay with me. I can't just plug a 3 and a 0 in because that's not back to where I was. What do I have to do? Replace that with a 2x. So what do I end up with? 1/2 what?
1/2 of
F of
F of
6 minus F of 0. Let's take it to another game, I guess. I'll talk more to you about that kind of stuff. But remember, our rule for a fundamental theorem that f of x, integral of f of x is big F of b minus big F. That's if it's x, single x, or u, single u. If it's anything else, you got to do u substitution. All right, enough on that. I don't think I asked you anything like that, but
I hope not.
might have been a bonus. Who knows?
Is that what you did?
What about number 9? Write an integral expression without absolute value that would represent the total distance traveled on that interval if the velocity is given by this. So first of all, if I give you velocity, how do I find distance? I would integrate to find change in position, but that doesn't give me distance. I would use absolute value to make it distance, right? Oh, but unfortunately, I can't use absolute value. So I have to make all of these segments on this graph positive. What do? Set that equal to 0, see if it crosses. Sure enough, you solve for x and you end up getting plus or minus 3. Or you factor it 3 minus x, 3x, you get 3, negative 3. Are any of those a concern to you? Positive 3 is in that interval, right? So the integral from -1 to 3 of velocity, the integral from 3 to 5 of my velocity, and how do I tell which one's positive or which one's negative? So I like plugging in a 0 in this one, it's positive, so I don't need to change that. If I plug a 4 in here, it's a negative y value, so it's below the axis out there, so I do need to change that. And that is the integral expression you would use to find distance. And if it says integral expression, walk away. Don't bother doing all the math of that. What about number 10?
It would just be e
So what's in play here to find f prime?
to second.
Second fundamental theorem. So I'm ddxing that, I'm ddxing that. There's your f prime. And what happens here? X cubed goes in, e to the there, x cubed. But what else? Times the derivative of that, 3x squared. Probably wouldn't be written in that order, but that's fine if you want to look at it in that order. What about number 11? Nice problem here. It really kind of checks a little bit of everything. So a particle is moving along the x-axis so that the velocity is given by that v equation. The position, x of t, is 5 for t equals 2. What's another way of writing that? X at 2 is 5, x of 2 is 5. Okay, and what relates velocity and position? Derivative or an integral, right? So right here it says, write a polynomial expression for the position of the particle.
16.
Now the position is not change in position. Position is what?
Just the function.
The position is the change in the position added to my initial position, or where I began, or subtracted from where I ended. Okay, but this says write an expression for the position of the particle at any time. So help me out.
Is it not just 6t minus 2?
So the integral of 3t squared minus 2t minus 1 would give me the change in position, right? All I know is what? Time 2. So if all I know is time 2, what can I do with this? I need to have that somewhere in here, right?
0. So you can put 0
So 2, well, I don't know anything about 0. I want to know at any time. So if I want any time t, what can I do?
Plug it in x.
Plug it in x. Now it said time t, so I really want to use a t. And then, you really don't want that t matching all of these. You want it to end up being a t when you plug it in. So really, you'd probably be okay here, but you really ought to go back and probably change all these t's to x's. And I know that's bothersome for some of you, but these shouldn't match that. So if I want to end up with time t, then change that. But I'm not going to count off if you don't. Now, what is that equal to? Because this is just my change in my position, and I want to know my position.
Just x of t minus 2.
X of t minus x of 2. So if I want to know my position at any particular time, couldn't I move that to the other side? Move this over here and say, there's my formula for change in position. For my position at any time t. Does that make sense? B, what's the particle's average? Yeah.
So for A, that's an okay answer. For it asking
Is
for
that
a
a polynomial expression?
We have to simplify.
Oh, now that's a good point. Yeah, that would be the calculus. That would be the expression. If I said polynomial expression, you probably want to go ahead and clean all that up. I guess I did do that in my key. So yeah, you would have this. I don't know. I'd probably on a test just say stop right there because I'm wanting you to have more chance to do more calculus. But yes, you would probably go ahead and integrate that. So if I was going further with this, I would say since x of 2 is 5, I can plug a 5 in there. By the way, I would want to plug 5 there. I would want to do that. I would have a 5 right there, and I would integrate that and get x cubed minus x squared minus x from 2 to t. Are you with me? And then I would go ahead and plug the t in there. T cubed minus t squared minus t. I'd plug the 2 in there. 8 minus 4 minus 2 is 2. Right? You still have the 5 there. And when you clean all this up, you get t cubed minus t squared minus t plus 3. So that's what I would probably want to have if I said polynomial expression. But I would probably only say expression, so you could stop right here. X of t equals the change added to that initial 5. And if you're thinking to yourself, but wait a minute, what if I want to know the position at time 1? That happened before time 2. That's okay. This would probably end up being negative, it would be a different value. It'll figure itself out. You don't have to worry about that. Okay? C, total, yeah.
For that one, I just integrated the velocity function and then did C and then plugged in the point and found the equation. I got the same thing.
That's the same thing.
Okay.
Yeah.
A lot.
Is it?
Yeah, just integrating the function and then plugging in C.
Yeah. I would hesitate to do that from this perspective. A lot of times you're going to have expressions just written as your answers, like written like this with the fundamental theorem. But really, that's what you're doing. See, I'm actually plugging that point 2 also in. I'm just plugging it in a different way. There's your plus C. You had to find it, and you found out it was. Did you find 5?
Well, for C, I found 3.
You found 3. Okay. Yeah. So you're kind of finding it by plugging the 2 and the 5 in. And I'm acknowledging the 2 is going to get plugged in there to give me this. The 5 is getting plugged in here. And the sum of those give me the 3. So it really, you had to plug 2 in for X, right? I had to plug 2 in for X. I just did it manually and got that. You had to write 5 equal 5. I had 5 already in the equation. So it's going in there. But yes, I think your work would be fine. But if the question was write an expression and the answers were written as integrals, you might look at that and go, what the heck?
Yeah.
So,
Okay.
but yeah, in the end result, I'd be fine with it if the question was to write the polynomial equation. Find the total distance. How do I find total distance? Do what?
Oh.
Oh, sorry. Yes. Find the average velocity, part B. How do I find average anything?
Take the integral.
You integrate that thing. So what is it? 3t squared minus 2t minus 1. Integrate that. It says on the interval from 0 to 3. And then what? Divide by 3 minus 0. That's your average velocity equation. And if you missed that, guys, again, you got to help me understand why that's hard. Average velocity, plug it in there. Seeing it? What if I said this? Find the average acceleration. Same question, same information, find the average acceleration. So this is average velocity. Now I want average acceleration. Well, what's the formula for average acceleration? Integral of A of t dt. I mean, forgetting any of this, isn't it integral of A of t dt from 0 to 3 over 3 minus 0? Isn't that what it would be?
Yeah.
And what happens when you integrate acceleration? You get a change in the velocity. Right? Can you now use the velocity equation to answer this question? Yeah, you just plug 3 in there. 27 minus 6 minus 1 is 20. Plug a 0 in there. Negative 1. 20 minus a negative 1 is 21. 21 over 3 is 7. So I would have my average acceleration. And I can find both of those given the velocity equation. All right, what about 13? Trapezoidal approximations. Let me show you what I saw a lot of you doing on those quizzes. You're showing me you kind of know the formula. I'm going to write it out. You tell me what I did wrong. You're like, okay, 4 intervals, trapezoid approximation. So the integral from -2 to 6, 2x minus 1/2 dx is approximated. And this is what I saw. 1/2 times the base. So the base is 6 minus a -2 over the 4 intervals. So the base is 2. And then I saw this. Okay, start with a -2. And then I got to add 2 to that. And then 1/2 base. And then go to the 0 and add 2 to that. And then just keep doing this. What's wrong with this?
You didn't use the function at all.
I'm using the x values, but I never plugged them in to get the y values. I saw a lot of you and a lot in the other class do that. I don't want -2 and 0. I want the y value at -2. I want f of -2 and f of 0. I want f of 0 and f of 2, f of 2 and f of 4, f of 4 and f of 6. And yes, all that cancels, but I would show that setup. So really, all I have left, f of -2 is what? -4 minus a half, what, -9/2? F of 0 is -1/2. That's what I really have here. Here, 1/2, 2, f of 0, -1/2, f of 2, 7/2. Are you tracking with me? Make sure you're finding those y values. That's true on all of the stuff that we do. Left-hand approximation. 4 intervals, same base. So, same thing. So I want the base, which is 2, times the height where? Where do I start if it's a left hand?
One more.
I start there if it's a left hand, right? If it's a right hand, I start one base to the right of -2, which would be starting at 0. But I'm starting at -2. But I want the y value, the height, to go with that base. So it's the f of the -2. Base times f. The f of 6 would be the left side of the next one, and that's too far. So you got to find that, right? F of -2 is -4, -4.5, -4.5 times 2. F of 0 is -1/2. Yada, yada, yada. But don't forget to find those y values. And again, I just don't want an answer, guys. I want you to see. And I have a lot of people that factor out the 1/2 and that factor out the 2, and they're using those formulas. Great. Y'all are a better, honestly, capability-wise, huge. We'll see what happens at the end of the year on that test. But you guys are a brighter group than I normally have. And I normally have bright groups, but y'all are a much brighter group. So I would imagine a lot of you would do this and use that little formula where you just factor out the 1 and the 1/2, right? And then you don't need all that writing right there. And then some of you even really know the formula where you're saying stuff like f of -2, and then 2 f of 0s, and 2 f of 2s. You know, you follow me? And you're welcome to use that formula if you want. But normally I'm only going to ask you 4 intervals, something like that. So it's not that hard to write them all out. All right, what else do I want to ask you? 14. Love this question. It's asked all the time on the AP test. So if f of x is that, compute f prime of 4. I give you x values, f of x values, and f prime of x values. So if I want f, first of all, let's find what f prime is. What is f prime of x? What do you do? I would have to take the derivative of both sides. What does that look like? Right there. Second fundamental theorem, right? So this is telling you to plug that in. F of x squared times what? 2x. Right?
Correct.
So for me to find f prime of 4, what am I doing? I'm really finding f of
X squared.
which is 16 times 8. Because to find f of 4, 4 has to go in for all the x's, right? So what's f of 16? 5 times 8, 40. Such a missed question, and really not that bad if you just know your stuff. We got time, right?
Time flies when you're doing that.
There's only one other one I wanted to look at, so we actually made a pretty good time. Hey guys, do as much as you think you need to do, and then a little bit extra. All right? If you felt really good about everything I talked about today, I would think you're in pretty good shape. But you never know, man. Do some of these practice problems. brush up. I know those quizzes might have been a little better, you know? Just saying.
After 4. Yeah. And then is there yes, yes. I didn't know like your I know he changed to my idea.
Yeah,
like,
he changed
I was like, that's French, and I was very confused.
Yeah, he and Madame Mars switched.